A Chinese research team has developed the ability to mind control a rodent, building a wireless brain-to-brain system that enables a human to move the rat cyborg through a maze. The research published in Nature Scientific Reports on February 4th detailed a brain-to-brain interface that connects a human brain to a computer, which then decodes and stimulates the rat brain to move. The researchers detail their methodology in a delightful section of the published paper called Rat Cyborg Preparation, explaining how they implanted electrodes in two sections of the rat brain. The researchers then trained the rats by using the electrodes to produce certain movements, which they wirelessly sent to the rat's brain via a tiny rat backpack containing the stimulator. Their first test for the rat cyborg involved a maze shaped like an 8-armed asterisk. The rat started in one arm of the maze and was tasked with moving into another arm. The human controller was fitted with the device known as an EEG to measure brain signals. The EEG was connected directly to a computer. The computer would then decode human brain signals and pass it through a model to stimulate the rat's brain and tell it to move in a particular direction. Using the EEG to measure the human brain signal means the researchers don't have to directly connect electrodes to a human brain. That's a good thing, but it makes the signal a little bit weaker. EEG measures electrical activity in the brain through the skull. EEG gives us a fast signal, but because the skull and skin are not very conductive and are quite thick, it doesn't give a good spatial signal from the brain itself. That comes from a biomedical engineer at the University of Auckland and not associated with the study. He compared the signal from the EEG to reading a book through several layers of frosted glass. Using such a method prevents information from quickly being passed from human brain to rat brain, which means there's a type of input lag that humans need to account for when guiding the rat through the maze. The brain signals for left and right can be decoded, but to move the rat forward, the researchers used an eye blink. However, on average, the rat cyborg still moved through the maze in around 3 minutes. The rat cyborg was also subjected to a slightly more complex maze with a predetermined route. On average, moving the 6 rats through a predetermined route through the maze was successful 90% of the time. Over 10 consecutive tests were given. Researchers have worked on brain-to-brain interfaces before with varying degrees of success. In 2013, in fact, a BBI linked a human brain with the rat, enabling the human to influence the movement of the rat's tail. In 2016, a human brain was linked up to a cyborg cockroach and enabled the human to move the cockroach through a S-shaped track with limited success. This is the first time, however, that a brain-to-brain interface has been used to complete a complex navigation task. In a previous paper, the team suggested that rat cyborgs may have great potential in search and rescue operations. The rats would be able to slip in and out of dangerous zones, potentially controlled by a human from a safe distance. Could they use this technology to navigate a rat carrying a small walkie-talkie and camera through a collapsed building looking for survivors? Well, it looks like that, yes, they actually could. But a hand-operated remote control would probably be a lot more reliable. For now anyway, the technology remains in its infancy, but it does begin to raise ethical questions about the use of mind control on other species. In the study published on Monday, the team notes that all experimental protocols were approved by the ethics committee at the university.